Welcome to our storage days. This is the first of 3 webinars that we're doing today. The other ones can be found on our website under our events page if you're interested in joining those as well. This one today is just a tech intro of OpenShift, and we're going to be listening to a presentation from Taylor Smith, who's on the line with us. She is a partner manager at Red Hat and also works with us at LINBIT to ensure that our products work well with Red Hat products.
All right. Sweet. So hello, everyone. Welcome to the tech intro for OpenShift presentation. Get this going. So my name's Taylor. I work as an engineering partner manager at Red Hat within our partner ecosystem organization. So my team and I work directly with partner companies and their product management and engineering teams. And we work with them to connect with Red Hat's product BUs and engineering resources to facilitate and manage their product integration and certification on our platforms. So in this presentation, I'm going to provide you with an intro overview of Red Hat's OpenShift container platform. So first, we'll cover the value and general business benefits that OpenShift provides. Then I'll discuss how OpenShift is Kubernetes, as well as what sets it apart from vanilla Kubernetes clusters. Next, we'll discuss the key benefits of the platform, including the security features, our ecosystem of hardware and software partners, the functionality and benefits of Kubernetes operators, and edge features and capabilities that OpenShift provides to complement the growing edge initiative at Red Hat. So after going over the general benefits of OpenShift, I'll dive into some of the highlights of our latest 4.10 release, as well as highlight some key features of the platform. And then finally, I'll end with OpenShift deployment options and a summary of Red Hat's product portfolio that complements OpenShift. So it's an exciting time in the tech industry. As we all know, business is moving faster than ever. Technology, open source communities, and new ways of collaboration are driving business innovation. Today, every organization in every geography and any industry can innovate, create more customer value and differentiation, and compete on an equal playing field. And with OpenShift, we're building on our heritage of Red Hat Enterprise Linux to provide a platform that enables your organization to innovate faster. Innovation at speed, the flexibility to adapt to a rapidly changing market, the ability to deliver new customer experiences and open new lines of business. That is what hybrid cloud delivers. So we built OpenShift for organizations to thrive in that world of hybrid possibility. OpenShift is built for IT operators, developers, and business leaders. IT operations leaders tend to focus on app modernization efforts. So OpenShift's automated processes and single platform for deployment, management, and day 2 operations simplifies operations and increases operational efficiency. OpenShift is also committed to empowering developers with the integration of the familiar tools that they're accustomed to using. We simplify the dev process. We remove roadblocks, providing a reduction in wait times, increasing overall dev productivity, and supporting a cloud-first mentality. And then finally, for business leaders across the org, OpenShift empowers the dev and IT teams to focus on innovation and drive business differentiating experiences that can not only grow the bottom line, but improve both customer and employee experiences. Red Hat OpenShift is a trusted Kubernetes enterprise platform. It's security-focused, consistent foundation ready to enable modern hybrid cloud application development and lifecycle management for any application in any location across physical, virtual, private, and public clouds, and in edge computing. So OpenShift is designed to deliver continuous innovation and speed at any scale. The platform is self-managed and includes the enterprise-grade Red Hat Linux operating system, container runtime, networking, monitoring, container registry, authentication, and authorization solutions. These components are tested together to ensure unified operations on any cloud provider or on-prem device you're deploying on. With the foundation of the trusted enterprise Kubernetes platform of OpenShift, we add productive enhancements to deliver an app platform with all the components you need that are fully integrated together to build, deploy, and manage containerized applications. So you can think of OpenShift as like a smarter Kubernetes platform because we streamline the install and upgrade experiences. And you can actually be up and running with a fully configured cluster in less than 15 minutes. And you have everything you need from metering and monitoring at the cluster level to application and developer services. You can also deploy any Kubernetes updates, security patches, and component updates with a single click. OpenShift is based on RHEL Core OS and can update the underlying operating system and scale at the node level, which is particularly useful when you deploy OpenShift on cloud infrastructure, because the entire cluster can scale up and down based on your application's needs. So let me explain how we build OpenShift from the Kubernetes foundation. So at Red Hat, across our product portfolio, we use a 100% open source development model to deliver enterprise products. There's no forking, no rebase, no proprietary extensions. The value that we provide is our ability to turn dozens and sometimes hundreds of open source projects into production-ready, stable, and secure enterprise products that we support over many years. When the upstream community declares a release is ready, we typically find hundreds of defects that we then fix in the corresponding downstream releases. And we can do this because we have been contributing to Kubernetes as well as the many other open source projects that OpenShift is based on since day one. And Red Hat is actually the largest enterprise developer of Kubernetes next to the project sponsor, Google. OpenShift is the leading enterprise Kubernetes platform to develop and run containerized applications at scale. Kubernetes is the open source de facto standard for container orchestration to automate the deployment, scaling, and management of your container applications. So on this slide, I'll touch on some of the fundamentals of OpenShift architecture and how it compares with vanilla Kubernetes clusters. OpenShift is based on Kubernetes APIs, and it's fully compatible with the kubectl command line tool. The OpenShift specific command line tool, or OC, complements kubectl as well as adds some additional helpers. If you have containers running on Kubernetes or another Kubernetes-based platform, you don't have to do anything special to make your container compatible with OpenShift. OpenShift is Kubernetes, but it adds additional platform-level management features for enterprise use cases. These cluster management tools like monitoring, security mechanisms, network management, et cetera, they all come out of the box with your OpenShift subscription. And it's also important to reemphasize that Red Hat is deeply connected and committed to the Kubernetes community upstream. We are embedded there. We are the second leading contributor behind Google, as I said, and we're one of the first companies to work with Google on the Kubernetes project. Red Hat Enterprise Linux, or RHEL Core OS, is the foundation of the OpenShift platform. Core OS shares the same kernel as RHEL, and it's optimized for running containers and managing Kubernetes clusters at scale. We also have a rich ecosystem of products from our software partners and hardware partners within OpenShift's embedded operator hub. And then lastly, OpenShift famously supports hybrid cloud, multi-cloud, and edge footprints. So here are some of the key benefits of OpenShift I want to highlight. OpenShift is security focused and delivers security for the entire stack. OpenShift has a wide variety of certified secure container content and services from a vast partner ecosystem. The platform offers streamlined install and upgrades, even in air-gapped or disconnected environments. OpenShift offers the benefit of application portability as well, with lower overall operational costs across hybrid cloud, multi-cloud, and edge. And then lastly, I want to just call out operators. The automated installation and day two operations are key features of OpenShift that make it easier to administrate and upgrade. Kubernetes operators, which is a core element of our OpenShift architecture, provide the foundation to make this happen. And this is not by any means a comprehensive list, but I just wanted to call out some of these most important features. So the first, OpenShift is built to inject the security you need across the application lifecycle. And the OpenShift platform extends security beyond the infrastructure layer to protect the entire stack. One example of a security feature within OpenShift is the container security operator that you can leverage to scan your active containers for security vulnerabilities. Additionally, you can leverage namespaces and role-based access control to achieve multi-tenancy and isolate applications running on your cluster from one another. We also have an expansive ecosystem, as I mentioned, of validated and certified partner products to utilize. So as I said, I work in the partner ecosystem organization within Red Hat. We are a platform company. We rely on our ecosystem of partner vendors as a result, like LINBIT. One of the key benefits of OpenShift is that we have this broad community of hardware and software partners, enabling you to access the latest networking and AI ML hardware and off-the-shelf ISV software to provide you the core capabilities you need, like database, runtimes, storage, and security. So let's shift a bit into the key benefit of OpenShift's simple installation options. We currently have 3 primary install experiences for OpenShift. The first is full stack automation or installer provisioned infrastructure, where the OpenShift installer tool controls all areas of the installation, including infrastructure provisioning, with an opinionated best practices deployment of OpenShift. So you can still input customizations when using the installer, but for the most part, it'll default to the recommended values. The second is pre-existing infrastructure deployments or user provisioned infrastructure. This is where administrators are responsible for creating and managing their own infrastructure, which allows for greater customization and operational flexibility. And last but not least is the newer assisted installer offering. So the assisted installer currently primarily supports bare metal deployments and has a very user-friendly UI to create your clusters with. OpenShift streamlines the cluster upgrade process as well. The OpenShift update service provides over-the-air updates to OCP, including the Red Hat Enterprise Linux Core OS. It provides a graph or a diagram that contains the vertices of component operators and the edges that connect them. The cluster version operator, or CVO, in your cluster checks with the OpenShift update service to see valid updates and update paths based on the current component versions and information in the graph. So when you request an update, the CVO uses the release image for that update to upgrade your cluster. The release artifacts are hosted in Red Hat Quay as container images. And all post 4.7 even numbered minor releases of OpenShift are labeled as extended update support or EUS releases. So these releases introduce a verified upgrade path between EUS releases, which permits customers to streamline updates of worker nodes and formulate update strategies of EUS to EUS OCP releases, which will cause fewer reboots of worker nodes. So the last core benefit I want to point out is the Kubernetes operators. So operators automate and simplify the management of complex applications on Kubernetes. They are app-specific controllers that extend the Kubernetes API to create, configure, and manage instances of complex stateful applications on behalf of the user. Operators build upon basic Kubernetes resource and controller concepts, but they include domain or app-specific knowledge in order to automate common tasks. They also enable you to program Kubernetes with the smarts it needs to effectively manage your app or service. Operators follow a basic pattern: observe, analyze, then act. And this pattern is about how a Kubernetes application is managed in a Kubernetes native manner. So in other words, allowing you to use the same Kubernetes APIs for managing your application that you've been using to manage the infrastructure. The operator is encoded to run and watch your application as it lives on the cluster, which ensures your app is running as intended, and then also addresses day 2 management tasks like upgrading and downgrading. And again, all of this is done in a Kubernetes native manner, so the way the user manages the app is similar to how the rest of their Kubernetes cluster is managed as well. For example, the usage of kubectl and the Kubernetes API. They're designed to automate routine tasks away from the users, which frees them up to pursue more meaningful work. So now I want to move into focusing on specific OpenShift platform features. I'll discuss some of the latest 4.10 release highlights, as well as give some attention to product roadmap information moving forward into future releases. So here, I just want to quickly call out several specific feature updates and enhancements in the latest 4.10 release that came out this past March. So for 4.10, here are a few of the highlights. OpenShift Virtualization continues to grow and advance, especially as Red Hat Virtualization moves towards sunsetting in the near future. OpenShift on ARM architecture is GA. MetalLB BGP is now fully supported. The external DNS operator is in tech preview. Installer support for Alibaba Cloud is now in tech preview as well, and IBM Cloud Installer Provision Infrastructure is GA. And then finally, we continue to make enhancements for telco 5G and edge use cases, as that initiative, as I mentioned, has been expanding quite rapidly. So this is a LINBIT event, so let's dive in with a little bit of storage information. So with 4.10, we're announcing new CSI or Container Storage Interface driver support for vSphere, as well as AWS EFS, IBM Cloud, Ali Cloud, and we're also introducing Azure File as tech preview. For CSI migration, 4.10 includes tech previews for vSphere and Azure File. And then as a reminder, the CSI drivers are automatically deployed at install or after upgrades. And we also want to note that in-tree drivers are still present and remain the default until CSI migration goes GA. Moving on to networking. So the OpenShift roadmap for networking is expanding to include every architecture and platform that we support today and are planning to support in the future. This includes single node OpenShift, HyperShift, MicroShift, multi-cluster, hybrid cluster, and globally unified networking. So this slide represents the roadmap goal for traffic into, out of, and between clusters in a unified way, so that ingress and egress are the same regardless of protocol, and to align how layered products such as OpenShift Service Mesh and OpenShift Virtualization operate. So we continue to work on Submariner project to provide enhanced multi-cluster networking capabilities with layer 3 and layer 4 interconnect, by enabling direct networking between pods and services in different Kubernetes clusters, either on-prem or in the cloud. So with Submariner, your application and services can span multiple cloud providers, data centers, and regions as well. So the key takeaway here is that the OpenShift product team is focused on unifying traffic in, out, and in between clusters across the hybrid cloud, and ensuring a unified experience that OpenShift always wants to provide that's secure and consistent across platforms. So on cloud platforms, Kubernetes services of type load balancer create a cloud native load balancer. Starting in OpenShift 4.9, MetalLB is the supported native load balancer for bare metal infrastructure deployments. OpenShift installations on public cloud providers always take advantage of native LB services. And until recently, we didn't have any out-of-the-box native load balancers or bare metal infra deployments with OCP. So this is when we decided to introduce MetalLB in L2 mode, starting with 4.9 as a supported load balancer for bare metal deployments. So we now support the BGP mode for MetalLB as well. With BGP, we advertise direct routes to Kubernetes services to other BGP participants outside the cluster. So basically, MetalLB running on every node establishes a BGP pairing with nearby BGP-enabled routers, and then tells them how to forward traffic to the service IPs. So the next networking feature is the DNS operator, which is now in tech preview. So customers need the ability to dynamically control DNS records of an external DNS server via Kubernetes resources in a DNS provider agnostic way. So this operator manages the upstream external DNS functionality and is supported in AWS, GCP, and Azure. And for the tech preview phase, there are several manual steps that need to be followed per the docs prior to the operator being installed, just to make a note of that. Okay, OpenShift Virtualization. So let's talk first about what we just announced as part of the 4.10 release in March. So enhanced data protection. To simplify data protection, this release of OpenShift Virtualization adds in integration of OpenShift Virtualization with the OpenShift API for data protection plugin, which is based on the upstream Valero project for backup and restore. Disaster recovery workflows will be coordinated with Red Hat's advanced cluster management. So we're working with vendors in this space to provide a cohesive solution there. And then there's additional hybrid cloud deployment options as well. So to provide platform consistency and the ability to run the same workloads in public cloud, and we currently allow running OpenShift Virtualization in AWS bare metal instances as a tech preview feature. So this release adds a tech preview for IBM Cloud bare metal instances, and we're also collaborating with additional cloud vendors based on customer requests. Operational enhancements. So service mesh feature of OpenShift is extended to now to support OpenShift Virtualization in this 4.10 release, which provides virtual machines running inside the cluster with the same security, observability, and traffic management features as any other pods in the mesh. And then lastly, workload acceleration through vGPU support. So with the addition of vGPU support, apps that require shared GPU resources can utilize OpenShift Virtualization. The vGPU feature slices GPU into multiple instances, supporting all kinds of GPU workloads from desktop onwards. Here are three main themes for where OpenShift Virtualization is going moving forward in future releases. Unified experience. The OpenShift Virtualization team is adding a new VM-centric overview page that simplifies VM operations and monitoring. This will be a single page to view the VM configuration, CPU, memory disks, GPU, and then to easily change them, get metrics on the running VM, and health and alerts. The second is security everywhere. So users will get access only to the VM template that they have RBAC access for when using the Create VM wizard. Additionally, with the combination of Hypershift and OpenShift Virtualization, you can run multi-tenant virtual OpenShift clusters. And then the third theme is platform consistency. We're providing a tool for low latency networking self-test on OpenShift Virtualization. This tool allows third-party vendors like VNF providers to easily build self-tests that will verify that the customer environment is configured properly and ready to serve VMs. And we're also building an ecosystem of data protection partners, and this is something I've been working on, that can provide an easy way to back up and restore. Emerging use cases across many industries continue to drive the shift from computing within central data centers to the edge, so creating opportunities to offer new intelligent applications using AI/ML, decrease bandwidth usage and costs, decrease latency for better app experiences, increase resiliency, and then to help ensure data sovereignty. So edge computing lets organizations place apps where it makes most sense to the business or application, even in the most remote of locations. So OpenShift on ARM machines is one of the big releases for this 4.10 release that had a lot of buzz, particularly when it comes to the edge use cases. The support allows you to run the latest AWS ARM-based instances, as well as bare metal servers. So you can currently only use EBS and NFS storage here, and the logging and the advanced cluster management teams are also enabling ARM functionality. You'll be able to run OpenShift on systems that have met the ARM system-ready, server-ready specification. To support edge workloads, we've also been aggressively strengthening our zero-touch provisioning solution, primarily for telco use cases. So to highlight a few 4.10 features, we now support deploying DUs to a CRAN hub. We've added better status reporting of the ZTP status with ZTP labels. We've tightly integrated ZTP with the topology-aware lifecycle operator. We now allow for custom manifests. We have a tech preview feature for policy-driven multi-cluster upgrades. We added a feature to allow the cluster operator to sequence single node OpenShift provisioning across an advanced cluster manager instance. And then lastly, we added support for pre-caching images and artifacts prior to an update or upgrade, providing as little downtime as possible. So as one of the most recent OpenShift offerings constructed specifically for telecom and edge-focused use cases, I wanted to make a special note of our single node OpenShift deployment option. So single node OpenShift, or SNO, gives you full OpenShift capabilities on, as the name suggests, a single node. In an SNO deployment, the control and worker node functionality are combined. So this allows for an overall smaller footprint, lower cost, and it supports a variety of disconnected scenarios while also providing the same OpenShift benefits that you're used to. The single node offering joins the previously announced 3-node cluster and remote worker nodes. So 3-node clusters are for sites that require high availability, but that need smaller 3-node footprints. The remote worker nodes are where only the worker nodes are in smaller edge locations, while the controller nodes are in larger sites like regional data centers. And then finally, single node, which provides software high availability, meaning if a container fails, Kubernetes is able to restart it, but obviously hardware failures can't be covered when we are dealing with a single server. And single node also provides that smaller footprint that is ideal when we're discussing edge scenarios. And then lastly, to wrap up, I want to go over OpenShift operational models and the broader Red Hat product portfolio that complements and enhances the OpenShift platform. So OpenShift is available in 2 operational models: a managed OpenShift service delivered by Red Hat and its partners on the leading public cloud providers like AWS, Azure, GCP, and IBM Cloud. Alternatively, we have self-managed OpenShift where you control the operational experience either on premises or in the cloud for maximum control, flexibility, and customization. And this is obviously the best option for our infrastructure partners, especially to have maximum control over installation. Enterprise organizations need to manage across multi-cluster and multi-cloud environments. So Red Hat provides solutions within our portfolio to address these challenges. Advanced cluster management allows you to monitor all your clusters, update cluster configurations, as well as drive upgrades. ACM also lets you deploy apps to multiple clusters from a single interface. Advanced cluster security integrates with the Claire vulnerability scanner to provide image scanning and vulnerability detection, and allows you to monitor cluster security policies like CIS, PCI, and more. And then Red Hat Quay provides a global registry to manage images across all of your environments. Okay, thank you so much. That's all I have for you today. I think we'll do questions next, of course. And then as I was telling the other folks, if I can't answer them in real time, then I'll find the answers and make sure they get back to you.
We also have a more technical presentation coming up next with Moritz, one of our developers too. So if you do have tech questions that are beyond our capabilities here, we can always answer them in the next webinar. We did have a compliment from Tamaz. Said nice presentation.
Thank you. Thanks.
Just give it a few more minutes if there's anything else coming in. In the meantime, do you know when the next in-person Red Hat Summit in the United States is? Is that coming up?
Yeah, it's May 10th and 11th.
Is that in Boston this year?
It is. Yeah, it's pretty limited, so it's like still a lot virtual, and like I can't go. They limited the invites to the elite like C-suite level. Maybe
next year.
Yeah, when I get promoted to CEO, they'll invite me.
Yeah, I love going to Red Hat Summit. It's one of my favorite events.
Yeah, it seems like it'll be a lot of fun. There's a lot of cool events teed up, cool talks.
Yeah, and hanging out with people, of course.
That too, yeah.
That's what I like. I enjoy speaking with people on the floor.
Mm-hmm. People in person.
Yeah. Doesn't look like we've got any questions, so I guess we can go ahead and wrap it up. And hopefully we'll see you all at the next presentation here. And I think it's about an hour here, 30 minutes.
Yes,
Well,
30 minutes.
Great. I'll be there too.
All
For the
right.
first bit.
We'll see you there.
All right. Thank you.